Hello everyone, welcome back to our channel. And today we are going to see about the Minikowsky inequality proof. Just in order to uh, have we have internals, right? So just to the purpose of internals, in order to cover the syllabus, we need to know the statements and proofs which are asked in the multiple choice questions. So I think the statements and proofs are enough, and if I get some time, then I will make more videos on applications. So please do check the before inequalities also to get a clarity. And the Minikowsky inequality statement is, let x comma y be any two random variables, with a finite expectations, which is nothing but expectation of mod x to the power of r should be less than infinity for every positive integer. So here try to learn the statement clearly, because in the internals they might can be asked what is the r here, whether it is a positive integer or a negative integer or none of the above. So it is r is every positive integer. It is an integer which is positive. In integers we have positive and negative. This is the positive integer. For every positive integer, r should be greater than or equals to 1. This r should be greater than or equals to 1, because if it is less than or equals to 1, which is nothing but the expectation of mod x to the power of r, which is 0, which is less than 1 means 0. If the power anything to the power of 0 is always equals to 1, here we need to prove that x comma y be any two random variables with finite expectations, which is nothing but expectation of mod x to the power of r is less than infinity for every positive integer r greater than 0. We need to prove expectation of mod x plus y to the power of r whole to the power of 1 by r less than or equals to expectation of x whole to the power of expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. This is we need to prove. If this r is less than or equals to 1, which is nothing but 0, anything to the power of 0 is 1, then how can we prove that this expectation will be the rth moment whole to the power of 1 by r? Right? This is the logic. This is the point. So you don't need to by heart it. When we know why we are taking the r value is greater than or equals to 1, you don't need to by heart it. Right? So now let us prove it. As I said in the before videos, using the Holder's inequality only, we are going to prove the other properties. Right? So here we will use the triangular inequality property and Holder's inequality property. Then for every positive integer r greater than 1, consider mod x plus y to the power of r. Therefore, mod x plus y to the power of r is equals to mod x plus y to the power of r. Now here I am multiplying and dividing with x plus y. Therefore, mod x plus y divided by mod x plus y. So if I take this mod x plus y to the upper side, denominator లో ఉంది, నేను న్యూమరేటర్కి తెస్తే ఏమవుతుంది, which is nothing but mod x plus y to the power of r into mod x plus y to the power of minus 1, and I have mod x plus y here. Therefore into mod x plus y. So I can write this as mod x plus y to the power of, bases are same, powers to be added. So r minus 1 into mod x plus y. Okay. Then this mod x plus y, if you consider the second term, do you know the triangular inequality? Which is nothing but mod a plus b is always less than or equals to mod a plus mod b. So I get here mod x plus y to the power of r is less than or equals to mod x plus y to the power of r minus 1, which is mod a plus mod b, which is mod x plus mod y. Mod x plus mod y. This is what we get from it. Now multiply this term with the second term. Then you get mod x plus y to the power whole to the power of r is less than or equals to mod x plus y to the power of r minus 1 into mod x plus mod x plus y to the power of r minus 1 into mod y. Now take expectation on both sides. Therefore expectation of mod x plus y to the power of r is less than or equals to expectation of mod x plus y mod x plus y whole to the power of r minus 1 into mod x plus expectation of mod x plus y whole to the power of r minus 1 into mod y. And consider this as equation 1. Now I said that without using the Holder's inequality, we cannot prove Minikowsky inequality. So now let us use the Holder's inequality in it. What is the Holder's inequality? Do you remember it? We know that we will take the Holder's inequality statement as p comma q be any two real positive integers, and 1 by p plus 1 by q is equals to 1, and this p comma q lies between 1 and infinity. Then expectation of mod xy is less than or equals to expectation of mod x to the power of p whole to the power of 1 by p into expectation of mod y to the power of q whole to the power of 1 by q. This is the Holder's inequality, right? So let us use this n to prove the further Minikowsky inequality. Now let us choose another constant s greater than or equals to 2. ఇక్కడ మనం ఇంకో కాన్స్టాంట్ ని అనుకోండి, which is nothing but s is greater than or equals to 2 we are considering, and so that 1 by r plus 1 by s is equals to 1. ఇక్కడ మనం p కమ q అని తీసుకున్నాం, ఇక్కడ r కమ s అని తీసుకుంటున్నారు అన్నమాట, అంత డిఫరెన్స్. And now we will use the Holder's inequality. So now take this has one part and this has second part. So take expectation of mod x plus y whole to the power of r minus 1 mod x. Okay. If you know the Holder's inequality is mod x into y is equals to less than or equals to this one. So try to substitute these values in this one. Expectation of mod xy is less than or equals to expectation of mod x. This is, consider this as x and consider this as y. So expectation of mod xy is less than or equals to expectation of mod x. Mod x is x plus mod x whole to the power of, take vice versa, or this is x or this is y. I'm taking this is x and this is y. So therefore mod x whole to the power of p. Now consider p has 1 by p plus 1 by q. So p is equals to r and q is equals to s. Okay. Therefore p whole to the power of 1 by p into expectation of mod y. I'm considering y has x plus y and whole to the power of q. Q is s and we have r minus 1. S into r minus 1. Therefore s into r minus 1 whole divided by whole to the power of 1 by q. Here in the q we have s, therefore 1 by s. Okay. And now consider the second part. Expectation of mod x plus y whole to the power of r minus 1 and mod y. This is, consider this as y and this as x or vice versa, whatever you might comfortable. And the Holder's inequality, we know this one. So mod expectation of mod xy is less than or equals to expectation of mod x, which is here the x is mod y. Therefore mod y mod y whole to the power of 1 by p. So here I have taken p is equals to r. Sorry, we need to take r here. Therefore r whole to the power of 1 by r into expectation of mod x plus y whole to the power of s into r minus 1 whole to the power of 1 by s. I hope it's clear. Because here y to the power of q and y we have as this total and into q, which is q is s, therefore s into r minus 1 whole divided by 1 by q, 1 by s. So substitute these 2 and 3 in the above equation 1. Okay. Therefore expectation of mod x plus y whole to the power of r is less than or equals to expectation of mod x to the power of r whole to the power of 1 by r into expectation of mod x plus y to the power of s into r minus 1 whole to the power of 1 by s plus expectation of mod y to the power of r whole to the power of 1 by r into expectation of mod x plus y to the power of s into r minus 1 whole to the power of 1 by s. And now see here we know that 1 by r plus 1 by s is equals to 1. And here we know that 1 by r plus 1 by s is equals to 1. Therefore take down the LCM, which is equals to, take the LCM, r plus s divided by rs is equals to 1. Therefore r plus s is equals to rs. We need to calculate s into r minus 1. So r is equals to rs minus s. So here take common s, therefore r minus 1. In the place of s into r minus 1, we can substitute r. So we get expectation of mod x plus y to the power of r less than or equals to expectation of mod x to the power of r whole to the power of 1 by r into expectation of mod x plus y to the power of s r minus 1. I can substitute r into 1 by s plus expectation of mod y to the power of r whole to the power of 1 by r into expectation of mod x plus y. In the place of s into r minus 1, I can substitute r whole to the power of 1 by s. Now see this one once. Here this term and this term is common. This is 1 by and take common in this. Therefore x plus y to the power of r less than or equals to expectation of mod x plus y to the power of r whole to the power of 1 by s. Then you will get expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. Then if you, this is in the multiplication. If this term is goes to this side, then it will become divided by. Therefore, expectation of mod x plus y to the power of r divided by expectation of mod x plus y to the power of r whole to the power of 1 by s is less than or equals to expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. Now see here, if I take this term to the upside, then it will become minus 1 by s, which is nothing but expectation of mod x plus y to the power of r whole to the power of minus 1 by s less than or equals to expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. So here the bases are same, so we add the powers. Therefore expectation of mod x plus y whole to the power of r 1 minus 1 by s less than or equals to expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. And we know that 1 by r plus 1 by s is equals to 1. Therefore 1 by r is equals to 1 minus 1 by s. So therefore in the place of 1 minus 1 by s, I can substitute 1 by r. Therefore expectation of mod x plus y to the power of r whole to the power of 1 by r is less than or equals to expectation of mod x to the power of r whole to the power of 1 by r plus expectation of mod y to the power of r whole to the power of 1 by r. This is what we need to prove. Therefore, hence proved. And if you like the content, please do like, share, comment and subscribe to my channel. Thank you all.